Good morning, everyone. Today we are presenting our final project, that is Farm Buddy. We are working as a team. Nishanth and Revanth are also here. These are the contents of our slides. We'll first go through the introduction, then give some background about the data. Uh, we'll talk about the data set, data design overview, implementation, and then conclusion. As we all know, agriculture is an important thing in everyone's life. It is a very important sector in every country. Every country depends on agriculture, and that's where we get our food from. So one such country with an abundance of agricultural land is India. India is also largely dependent on agriculture, and as this saying goes, uh, agriculture is the backbone of India's economy. In India economy relies largely upon the Indian agriculture sector. So, getting into some stats, the share of the agriculture in GDP increased by around 2% in 2021-22 when compared to the year 2019 and 20. So, it is very crucial for the farmers to understand what to plant and when to plant different crops. So this has motivated us to build a database system which can help farmers. So our data in India, basically, there are three major cropping seasons in a year. They are Kharif, Rabi, and Zaid. Kharif is from June to November. Rabi is from November to March, and Zaid starts in March and ends in June. And in the data set, we have considered there are many crops. These are the major crops which are grown in India. But for, we have taken a subset of the data set which has only first five crops, that is paddy, wheat, jowar, bajra, and maize. So with the data we have designed a database system which can visualize the agriculture lands on Indian map and suggest the farmers which crop to be grown in a particular season during a year in a time, and also predicts the price and yield of a crop for a future time. With this, I'll give it to Nishanth to talk about the data set.
Hi. So, as you can see, there is a link there where we have gathered most of our data from. We have put a lot of effort in gathering the data. We have collected few crops information like paddy, wheat, jowar, bajra, and maize, and um, we have written a code where you can see it's mentioned in the GitHub project. We have taken all that information, kind of um, took an average over the past of few years, and then finally we have built the input for the following MATLAB scripts. You can see we have used I2A2C script and the piecewise linear approximation to build the prediction constraints. So you can go to the link there for the complete project overview. And moving on, we have the design overview. We have seven entities, and we have out of seven, there are six entities which are related, and you can see there is crop, there is irrigation area, there is prediction price, prediction yield, and season. And moving on, we have all these constraints. As you can see, these are the samples. The complete data is in the GitHub, and this is a nice visual representation of India in the MLPQ system. Now Revan will be explaining about the implementation.
Thank you, Nishanth and Vaishnavi, for the beautiful explanation about Indian economy, dependence on agriculture, and how we are going to implement this information in MLPQ system. Let's see how the queries are built in the backend. You can see this is a nice representation of Indian map. over the agricultural areas, and then you can see those um, convex polygons as an irrigation areas over the states, and you can see on the left there are those are the relations we have created with lot of data in it. We went through a lot of sources and made sure that the data is valid and it could be a good help to the farmers. So let's see some of the queries we did on this. Yeah, these are the two queries where you can see wheat and paddy are retrieved based on their yield in 2020 uh, to see which states are providing more yield uh, in paddy and wheat. And in the next slide I'll show you the representation of this. Here you can see wheat is represented as dark green color and the paddy is as the orange one, and there is some overlap on this wheat over paddy, so we use the intersection function to visualize it better to find the common areas where paddy and wheat is grown more. Yeah, here you can see these are the intersection of wheat and paddy grown in 2020 having yield greater than 2500. And this is another query which is mainly important in our database. The main idea behind this project is to help the farmers to predict the price of a particular crop in the upcoming years. This will give a rough estimate to the farmer whether it's going to increase or decrease. So here you can see we are trying to predict Uttar Pradesh paddy price in Uttar Pradesh state in the year 2023, and this is the simple query we wrote for that, and results seem to be pretty accurate with the constraints we built. And next query is to predict the yield of a crop in a state for a given year, and you can see this output here is in kg per hectare, and this is the query we built for Telangana state to predict maize yield in year 2025, and you can see the result is 1175 kgs per hectare. And another thing our system could help the farmers is whether a farmer can find whether the given crop is favorable in that season or not. Given a month and a crop, we can just find whether it is favorable to grow that crop in that month or not. And you can see we have built the crop here by joining the three tables: impact, crops and seasons, and you can see the output whether jowar can be grown in kharif or not, and it is true that jowar is favorable to be grown in kharif season. So yeah, this is similar to the last one, just we want to find out whether it's working fine or not, so we have built one more query on this, and you can see that maize can be whether maize can be grown in rabi or not. So the answer is no, rabi season is not favorable for maize, so kharif is favorable. And another type of functionality we have in MLPQ is SQL aggregation, which can be used, which has been used to find the maximum yield of crop in each state. And you can see the maximum yield of every of crop bajra in the of crop bajra in every state, and you can see the result in there. And another functionality we implemented here using nested SQL is in the database we have to find which crop has given the maximum yield and in which year and which state has given this maximum yield. So we have built this query to find which crop and which state had the maximum yield, and you can see in the result that state ID 3 has given the maximum yield in the year 2080 and the crop name is maize. Yeah, Vaishnavi will speak about the conclusion.
Yeah, so as both of my teammates explained, we have built a database system and run some queries, and it showed the results are pretty accurate. So MLPQ was useful in building and visualizing the map and the agriculture lands. We have considered factors like seasons, and we have shown how the seasons impacts the crops based on the historical data, and we also tried to give some insights on which crop to be planted in which season, and also given some prediction on yield and the price for the future years. MLPQ was pretty useful as it has all the buttons available, and it is simple click to run the queries. And in the future, we are trying to incorporate more data to get better results and also give some animation on how the crops are varying in different states through years. With that, we conclude our presentation. Thank you so much.